What is he? It's just it's a constant, right? It's a number in my calculator, right? It's inside the calculator. It's the growth rate, right? The natural growth rate. K, or R, I guess, is the rate of growth, or rate of growth. Or, I guess, growth or decay, I guess we could call it, right? Because we just established this isn't growing, right? It's actually dying, right? So I guess the rate of growth or death. And then T is time. Now in compound interest, John, we remember in compound interest, T is always years. But in other, if it's not talking about compound interest, time could be in hours. Remember those WASPs? Hours, days. Okay, so let's see what we have here. A city has a population of 150,000 and it decreases by 8% per year. How many years will it take for the population to become 50,000? Okay, so according to my calculations, I think the 50,000 is the final amount, right? And the initial amount is the 150. E is in my calculator. I have R and T. Now, it says how many years, so I'm solving for T, right? So I should know what R is. So, what happens to this, what happens to this population if you're in doubt what this is, because this is a problem. The rate of decline, it is declining by 8% per year, but I'm talking about the rate of growth or decay of the population, right? So this population is definitely dying off, so I know the growth rate's going to be less than 1. But let's just, if you're a little in doubt about these guys, anytime you have declining, it's a little difficult. This is time, and this is population, we'll say. Okay? I'll say percent of population even, percent of population, right? Or, no, I'll just say population. At time 0, sorry, kind of screwed. At time 0, our population was 150. Agreed? Okay, after 1 year, because it's talking about decrease by year, how many people will I have left in the population? 13,000? That's how many people will be left? It's declining at 8% per year. How did you find 13? What did you do? If I'm just doing a table of values though, and I'm filling in my values, whoops, sorry guys. Started off with 150,000. I lose 8% of this. So how many people are left? How would I figure that out? Someone give me this number here. I lose 8%, right? So what's 8% of this? Okay, we lost 12,000 people, right? So 150 minus 12,000 is what? 138,000. Agreed? Now, if I wanted to find in year 2, what would I do? And I'm not going to do this all the way till I get to 50,000, by the way. There's a quicker way, but I'm trying to demonstrate something here. I'd have to find 8% of this number, subtract it. Agreed? But when you have a reduction, I'm not interested in the amount of people I lose. If they're telling me to study the population, I'm interested in the percent of people that I keep, right? So how I get this, if I just want to create this next number, you know what I'm going to do? I'm going to do 138,000. If we lose 8%, we keep 92%. Isn't that true? If you lost 8% of your wages due to taxes, you'd keep 92%, right? So the quick way is the actual rate of growth is 92%, or the rate of decline. Okay, so what we do is, this is actually 0.92. We're studying the population. This is how much of the population we keep, right? We keep 92% of the population. And we're studying the population. We're not studying the people who left. We're studying the people who stayed. Okay, so if we put all that into our formula, 150, erase. 50,000 equals 150,000 times E to the 0.92 t. And I'm going to solve for t. Now, I could keep doing this until I hit 25,000. The problem, though, is I bet the number of years isn't a whole number. It's going to be probably with a decimal in it. So I'll never ever get my perfect 25,000 using a table of values. That's why you need a formula. Okay? So let's see what we get here. 50,000 divided by 150 equals e to the 0.92 t. Now what are we going to do? Yeah, I'd probably simplify this. 1/3 equals e natural log, right? I would ln both sides. So ln of 1/3 equals ln of e to the exponent times t. Then those exponents can come down, right? Okay, so what happens when I have ln of e? If my base is the same as my argument, so the exponent has to be 1, so that's gone. So finally, ln of 1/3 divided by 0.92. So, where am I? Don't know where his logs are. Sorry guys, I think it works out right, I just can't find. Oh, here it is. log of 1/3 divided by 0.92. Whoops. Log of 1/3 divided by 0.92. Why am I getting something weird? Oh, ln, that's why. Ln of 1/3 divided by 0.92. Sorry, that's better. Why isn't it working out? It should work out, right? Can I borrow your oh no, you don't have one. Can I borrow your calculator, Joanna? Yeah, it should. Okay, ln, where's your ln? The ln of 1 divided 3, I'll go equals this time, divided by 0.92. Why isn't it working? It should work. It should work. T is equal to 13.18, right? Log 1/3 divided by, right, 0.92. Ln of 1/3. Why isn't it? Ln 1 divided by 3, right? Divided by 0.92. I just worked this one out too. What is going on here? There's something wrong here. Okay. I worked it out 2 ways. Hang on. Number 3. Yeah, 13.2 years. Why isn't this working out? Sorry, guys. Can anyone see when I'm not punching in? divided by 1.92. Okay, so 1/3 equals 0.92. For some reason, I can't figure this one out, why it's not working. And it should work, right? PERT. It also works if you just use A equals P R to the T, right? Because you did it this way, right, Joanna? PERT? I don't know why it's not working now, because it worked for me at lunch. This is how I did it initially. I'll just show you. I did A equals P to the R T, right? The base. So final, initial, the base, the rate of growth, the base of growth is 0.92. This is 150. This is 50. And this is my time, right? My number of years. Okay, so this way works for sure, but it should work the other way. My growth rate, or I guess my rate of decline is 0.92, because you're worried about who's staying in your city, right? To the T. So I still get my 1/3 equals 0.92 to the T. You could log or ln both sides, it doesn't matter. But you'll get ln of 1/3 equals T ln of 0.92. And then T equals ln of 1/3 divided by ln of 0.92, which works, right? Ln of 1/3 divided by ln of 0.92, and we get 13.17 or 18 years, which is 13.2 years. Okay, so that works. Just a final initial base, a growth rate to the number of years, except I just don't know why the E didn't work, because it worked before. I'll work on the E way again, and we'll see why that didn't work. But you should have been able to use the natural log too. Just don't know how. I don't know. I swear it worked about 10 minutes or 15 minutes ago, just before I came here. But I'll look at that one again. But like I said, for now you'll always be given the formula, so you shouldn't have to struggle with which one to use. The only thing I'm going to tell you, the takeaway from here is, if you're studying the population, you're studying the growth rate of the population, not how many they left, but how many they kept. So in a decline situation, if they're losing 8%, the complement of that is, like the leftover, what remains is the 92, right? If the rate of decline was 30%, if you lost 30% of the people, you're going to keep 70, right? And just remember, when you put that base in here to show, like this was a 0.92, right? That means this number should always be less than 1 if it's a population that's dying off, right? Okay. How about I give you a little bit of time to keep working on those two? After the break, I'm going to do something a little different for review, okay? To help you review for your test on Monday. I'm concerned, sometimes I don't see a lot of work being done. Some people do a lot of work, some people aren't doing enough work, so I just want to make sure everyone's going to be prepared. So I want to do something a little different for review. But in the meantime, get to work on those two assignments. I know no one's done those, completed them, so I'll kind of walk around and help you out if you need it. I'll also do that other question